Hey there, and welcome to the Confident Chemistry Teacher Podcast. I'm Kim, your go-to chemistry coach for engaging teaching strategies and simple solutions to the everyday challenges chemistry teachers face. Let's get this reaction started. Hey everyone, welcome back to another episode of the Confident Chemistry Teacher Podcast. Today I'm going to be talking about atoms. I'm going to talk about my sequence that I teach it in. It's probably pretty similar to yours, but it's always kind of cool to hear how other people are teaching it. I'm going to share a few of my favorite resources I use, and then I'm going to talk about how I differentiate between Chemistry 1 and Chemistry Honors. So my order that I teach this in are, I do, of course, parts of the atom, your nucleus, your electron cloud. I do mention that term shell. I know it's old school, but I think it's helpful for kids. We, of course, talk about subatomic particles. How do you calculate them? What are their charge? What are their size? And then this is like a sticking point for my kids every year, is just knowing what the atomic number is, the average atomic mass, and mass number. I really just think knowing those definitions comes with like a lot of practice. I also like to teach about Bohr models in here. And again, I know Bohr models are only really good for hydrogen atoms, but I really think they are good for teaching about the octet rule, about losing and gaining electrons. So we definitely start off with talking about the Bohr model here. And I like to think of it as a teaching tool. I sometimes joke with my students, like when I teach AP chemistry, I'm like, okay, we told you a lot of rules in chemistry honors, and then now in AP chemistry, I'm going to tell you that we kind of lied to you and the rules can change a little bit. But again, I think it's like a good stepping stool for helping kids understand what's going on. We also talk about ions, the octet rule, and then using the periodic table to identify the ionic charges. Now, this isn't like the central purpose of this unit. Like, I really think the parts of the atom, atomic number, mass number, those are the things that are really key. But I teach it in this unit because I really believe in like spiral curriculum. So that's like where you teach a topic and then you come around and hit it again and you come around and hit it again. So again, not that you have to teach it here, but by the time that we get to nomenclature where kids need to know about those charges and why do atoms develop charges, they've heard it 2 or 3 times because they'll hear about it in electrons later. So they've heard about it a few times before we start into a new concept about having to write these chemical formulas. And then of course, you guys, we talk about isotopes here and calculating average atomic. Now, there are some things that teachers teach in this unit that I don't. And remember, like, we're all just doing the best we can. So if you teach something, it's not a criticism. I just want to give like a quick explanation about why I don't teach it. So the first thing is the history of the atomic model. I find that this is kind of embedded in the beginning of a lot of atoms chapters, and I just don't want to put it here. I actually put it at the beginning of my electrons chapter because I feel like kids have a better understanding of the terms protons, neutrons, electrons by the time we finish this chapter on it. So for me, it makes more sense to teach that development or that history of the atomic model when we get to electrons. I also used to teach moles here, so I just feel like kids' math skills are not as amazing. And I know I just said I really believe in spiral curriculum, but I feel like the purpose of this unit for me is for the kids to get those fundamentals down of an atom. And so incorporating moles, which is maybe like a math topic that they're not super awesome with. So now I just save moles until like right before Christmas break or right after Christmas break. And I really just do that as a separate unit going on. So again, a little bit of spiral curriculum here because I really do think the ions is easier than calculating moles. I just want them to be able to, off the top of their head, calculate the number of protons, neutrons, electrons. Okay, so I'm going to share a couple of my favorite resources with you. This first one is not exciting. I'm so sorry, but I do love me a good Google Slides presentation. And I think I mentioned when I talked about my scientific math unit that in the Google Slides that I create, I have a lot of practice problems in there. So that provides a really good opportunity for me to see if the students are understanding the concepts as we're doing the lecture. Usually on the slides, I have 5 questions on there. And I like the whole I do, we do, you do thing. So usually I'll do like the first question with them, and then we'll do the second and third question together. That's the we do part. And then the you do part is those last 2. I'm walking around the classroom and I can just make sure like, are the kids understanding this? Do I need to go back and give some more examples? Another activity that I really like is the PBS ChemThink atomic structure activity. And I'm going to put my packet for this that I have, just like I'm going to share it in the show notes. I'm also going to put like a practice worksheet that I have in there if you're looking for a different worksheet. So anyways, I really like this activity because it's online, it's interactive, it's super simple, and it really helps kids see what's going on when you put these subatomic particles together. I know a lot of people like the PhET. I feel like the PhET can be a little complicated sometimes, and this is just like super simple activity, and it gives you that instant feedback, and the kids really, really enjoy it. The other thing that I really like in this unit is, I know you're not going to be shocked by this one either, is POGLs. I do the isotopes POGL and I do the average atomic mass POGL in this unit. Now, if I had to say, like, if you were short on time and only could choose one, I would do the isotopes POGL. I think it's great for writing isotopic symbols, then calculating the number of protons, neutrons, electrons. And then the other thing I like about this POGL is that at the end, it mentions the different isotopes of hydrogen, like protium, deuterium, and tritium. And I do a lab called the isotope and marshmallow lab. I'm sure you guys have probably done it before. If you haven't though, I'm gonna explain it in more detail like in a future episode. But again, talking about spiral curriculum, the POGL talks about these names, which seem kind of weird, like protium. You're like, what is that? But then, you can always make that reference to prophase in biology. It's like the first phase. And so like this is like the isotope of hydrogen that only has the one subatomic particle. Deuterium, dew means two, so it has two subatomic particles. So anyways, I like that POGL because it kind of leads into that fun foodie lab that I do next with them. The other POGL is the average atomic mass is the average atomic mass POGL. And this one, again, all POGLs are great, but I really like that they show a couple of different ways that you can calculate the average atomic mass. I kind of do what my professor did, and I just take those percents and I convert them into decimals, but I know that's not everybody's jam. So when we do that POGL, it has like 3 different sets of calculations in there, and it has one where it takes the percent and changes it into a decimal, and then the other one is like they're basically just multiplying everything on the top and then dividing it by 100, which I think is a really great strategy for those students that really struggle with those percent to decimal calculations, just to divide at the end. So I like to point that out as like, yo, you guys, are you struggling a little bit? Well, check this out. This is a different, maybe an easier way for you to calculate this. And then when it comes to quiz or test time, I'll totally take it either way, right? Because math is math. It's going to get you to that final answer. Then, of course, I have that isotope and marshmallow lab. And then the other lab, it's so old and it's so corny, I love, is the beanium lab, you guys. I just get so corny with my kids when I do this. It's called the beanium lab. And so, you've probably seen really cool candy labs, but these days I'm so tired of spending my own money, and the beans have lasted forever. They still are getting the same concept out of the beans. And I just did feed them marshmallows a few days ago. I can't keep feeding them sugar all the time. But anyways, the beanium lab is like super good for the kids to make those calculations. It talks a lot about abundance and percent abundance, which just that term freaks kids out for some reason. And then I always like to get real cheesy about it, shocker. And I'm like, okay guys, today we have discovered a new element and we have been assigned a job. We need to figure out the average atomic mass of it, and we need to work with its 3 isotopes: navy-benium, pentobenium, and kidney-benium. And okay, so you kind of hear the cheesiness in my voice. Plus, though, some of these kids don't know what these beans are, so I feel like there's a little real life lesson in there. If you're interested in that lab, send me a DM. I'm sure if you Googled it, though, it's kind of like a classic. People have been doing it for like 100 years. Now, a quick hot take that I want to talk about is average atomic mass. Should you teach it? Should you not teach it? I am on the camp of let's teach it. The reason I think for this is a lot of my kids are going to go on and they're going to take either like a college prep class, chemistry class, they're going to actually take a college chem class. And even if they don't, I think just this problem solving of doing math and having a procedure of how you calculate something is really good for kids, and it really builds up their math skills. In addition, at my school, we have what we call a weighted average. So 80% of their grade is summative and 20% is formative. So I think this is like a natural kind of helpful way that, kids could be calculating their own grades, or it's like a good analogy to fit in with like our grading scale. So let me just kind of talk about how I do this. So Chem 1, I want kids to be able to give me the definition of it. I want them to be able to tell me like which formula, out of a multiple choice is the right formula for calculating average atomic mass. I want them to be able to tell me if 20% has an AMU of 15 and the other 80% has an AMU of, or a mass of 20, is the mass going to be closer to 15 or is it going to be closer to 20? And then of course they should hopefully say the average atomic mass when you calculate it, even though they don't have to calculate it, would be closer to that 20 AMU mark. And then I know extra credit's kind of like for everybody, but I definitely do offer an extra credit question for my Chem 1 kids to answer on their atoms test. Again, in chemistry, it's kind of weird. I think some kids are either really good at math. I mean, I realize I'm generalizing here. Some kids are really good at math. Some kids are really good at memorizing things. So those kids that are really good at math, this kind of buffers them up. It kind of makes them like, oh, I can do chemistry. So anytime, kids can get some extra credit, and for something that's not that easy, I'm okay with. Then for my chemistry honors kids, I want them to do everything that Chem 1 could do. And they're actually, that calculation is not extra credit for them. So just like a standard, like average atomic mass calculation they have to do. But I have some real smart kids in my honors class. And this is really a good way to figure out like, are they going to be good for AP chemistry? Or, kind of gives me an idea about like, maybe like where should they go? And so for them, I'll go ahead and I'll have an extra credit question for them where they have to calculate the percent abundance. That's the one like where you give them the mass of each isotopes. And usually it's just 2 isotopes. And then you give them the average atomic mass and you have to have them figure out the percent abundance. You assign X to one isotope and then you assign 1 minus X to the other isotope, and then you're able to calculate out those percentages. It does require a little bit of algebra, but usually my kids in chemistry honors have had algebra before. And then if I have like super fancy pants kids in there, and I mean that as like a super compliment, like they're super smarty pants, is that I'll give them one like where it's got like the 3 isotopes, and they'll, I'll be like, the one isotope has 25, and so then they have to do like X and then like 75 minus X, or kind of not as hard. I'll be like, it's strontium, and I'll give them the masses of the other isotopes. They just have to look up average atomic mass of strontium, and so sometimes that can even trip up some kids. But I really think that average atomic mass is a skill that you can teach, and it really can, build their confidence in like what they know. And then of course your Chem honor students, you want them to be prepared for college chem, and they're definitely going to see that calculation when they get. So again, I just want to remind you kind of the couple of things that we went over today. My sequence, it's pretty traditional. We do the atomic structure, we do subatomic particles. Not traditional, but for that whole spiral curriculum, I like to do ions and the charge on the ions and the octet rule. I like to get that octet rule in there as many times as I can for kids. And then, of course, we talk about isotopes and average atomic mass. I definitely teach average atomic mass to all my kids, but as I just mentioned, I do differentiate on what I'm expecting the students to know from one level to the other level. And then if I had to say like, if there's one thing you haven't tried, try that PBS ChemThink activity. I think it works really, really great, and it's really like a good review of the concepts that you did in your lecture. I do want to remind you that I'm going to attach those 2 things in the show notes, which is the practice worksheet and then that PBS ChemThink packet that I use. I do want to remind you that I have started a Facebook page for the Confident Chemistry Teacher podcast, or like for you guys that are listening, which is super awesome, by the way. I have like a Facebook group, so it's under that same name, so you can go ahead and just look that up. Join us. We're, just getting together a group of like positive teachers who just need some help. In fact, I'm going to post a question about classroom behavior tonight that I'm going to need some help with. And then if you're interested in joining my email list, check out the link for the lab day safety activity. It has like a couple of cool things in there that are going to help you out for lab day: a pre-planning sheet, a Google Slides template, and like a lab station sign-up sheet. So those should all be super helpful for you guys. If you guys are teaching atoms right now, if you've recently taught atoms, you did something super cool. I haven't gotten there yet this year, so I'd love to hear what you guys are doing to make my lessons more awesome and more engaging for my students. And then you guys, as always, thank you so much for listening. I really appreciate it. So keep experimenting, keep inspiring, and keep being awesome in your classrooms. Happy teaching.